Welcome to video 19 in a series of introductory videos for SolidCAM. This video's topic is the drilling toolpath in a turning or mill turn module, as well as the use of milling toolpaths in a mill turn module. Okay, so let's begin with the drilling turning toolpath. Again, you can find that inside of the SolidCAM turning tab on the ribbon, or you can right-click, add turning operation, and drilling. Now, on a lathe, you're basically just drilling down the spindle axis, down the center line. So that's why in this operation manager, there is no geometry. The geometry is literally just going to be 0, 0, the origin. So we skip right to drill. Okay, and I'm just going to choose my drill here, green check mark, making sure that the mounting is correct. Now in this case, with a simple lathe drilling operation, all we're really doing is coming from either positive Z or negative Z, the spindle axis. Levels, once again, is just safety distance. In this case, safety distance in a drilling would just be along the Z-axis. Under technology, we see the particulars of this toolpath. Now here for drilling, again, we're drilling down the center line, so the only parameter here would be where do we start and where do we end. So drill start, you can choose a face or a point, just like you would anywhere else inside SolidCAM. So there is our drill start. And our drill end, I'm just going to choose the back face of the part. Once again, the color coding indicates associativity. So in this case, you can actually remain associative to those faces. If the part changes in any way, the depth of this drill will change. And just like all the other drilling toolpaths you saw in the milling section, you actually have a depth type of cutter tip, full diameter, or diameter value. In this case, I'm going to go full diameter. If your drill has been defined in your tool library as a drill, but it really is a flat bottom, then you can just add the flat bottom right there. And as always, on the right side here, drill cycle, we can just choose our drill cycle type. In this case, here's my G83. Click on the data button, and you can get to the particulars of this drill. So if I just do a save and calculate, we'll see that the drill really is just going down the center line again. And if we do a simulate of that in our turning simulation, we'll see that we basically just drill down the center line. So very simple. Drilling on a lathe, very simple, just down the center line. Now the reason we have a separate video for this is because of the second topic, the using milling toolpaths on a mill turn. Or to better describe it, what to do with the material boundary. Because if I were to suppress this drilling operation, let's just suppress it, and let's add a drilling operation from the milling library. So we go add milling operation, drilling. Same operation that we saw in video 7. This case, because we're doing a milling operation on a mill turn, we can choose the geometry. In this case, it's going to be a drill point. It's just going to be 0, 0 once again. But the difference here is we're actually choosing it because this is a milling operation. I'm assuming we're having live tooling. Let's go to tool. Let's just choose the same tool. So that same drill. Mounting in this case is still going to be in the positive Z direction because in milling operations, positive Z is the tool axis. And if I click on this icon here, we'll see that it still comes in the positive Z direction. So we're still good there. Levels are exactly the same. I'm just going to choose that face and that face. Full diameter. And under technology, we'll still give it the G83. Okay. So if I do a save and calculate, and let's do a solid verify this time. So the setup is still a lathe setup, or in this case, we're imagining this is a mill turn. Press play. We still drill the hole down the center. Now, where we differ in the drilling types is, one, this is a live tooling. So this is actually the part is staying stationary and the drill is spinning. Whereas on a lathe drill, obviously the tool, the drill bit, is stationary and the spindle is turning and the part is turning. And that's how we get our drilling operation. If we switch this to a turning simulation, let's take a look at this real quick. So I'm just going to step through this so we can see the part profile and the stock profile. If I press play on this milling drill toolpath, nothing happens in the turning simulation. That's because inside of a mill turn module, such as the one we have open here, the milling and the drilling toolpaths don't update the stock in the same way. This is a turning representation, and the milling toolpaths will not be represented here. So even though the drill went right down the center, and we saw in Solid Verify, it showed everything, the turning and the milling, nothing showed there. and we'll see the effect of something like that. So the drill definitely went down the center, but the updated stock of the turning didn't show anything. So if I bring up a turning toolpath, so this one is actually, if I show the contour, the inside contour. This is the boring operation. This is the operation you would have seen in video 17. If I synchronize and calculate this toolpath, we'll see that because the drilling operation, the milling drill operation, did not update the turning stock, this toolpath thinks it has to start from dead center and mill out. This will obviously collide, this will crash. If we go to turning operation, there we are. So it's definitely crashing. Okay, so what do we do if we need to use a milling toolpath? Now this goes for all milling toolpaths you want to see update the turning stock. Well, if we open up the mill drilling toolpath again, the way we programmed it is correct. The only thing that's missing is the update of that turned stock. So if we go to miscellaneous parameters, click on update material boundary, what we're now telling SolidCAM is whatever this particular operation is doing, whether it's a profile pocket or in this case a drill, I want it to update that material boundary, update that updated turned stock to represent whatever this toolpath happened to do. Now, in many cases, a milling toolpath might be a pocket on the OD. It might be some sort of profile on the outside. Really doesn't matter in terms of a turned stock. But when you're doing drilling, it does tend to matter because obviously here we did a pre-drill with a live tooling rather than a lathe-based toolpath, and we want to see that update the turned stock. So now you see that little black asterisk next to the internal operation. If I do a synchronize and calculate on this one once again, we can see that the toolpath is now up to date. Let's take it a little further. Let's go right into the turning. So we can see now that our turn stock is up to date, and the internal boring operation knows there's an update, and now it just does the turning on the outside. Or sorry, turning on the inside. So again, that is any milling operation under miscellaneous parameters in a mill turn module. You should see the button here, update material boundary, and that will update that turn stock to reflect any toolpaths you've done that might affect that updated stock that's used in turning. Okay? So any questions on mill turn module, the drilling toolpaths in both mill or turning, the mill drill toolpath you saw in video 7. This one here is the lathe toolpath for drilling. You can call us at 1-866-975-1115 extension 2, or you can view the rest of the videos for all the other toolpaths from SolidCAM. Thank you for watching.